In 1930, a single invention destroyed economic empires that had controlled human civilization for 5,000 years. These weren't banking dynasties or oil cartels. These were salt empires, networks of power so dominant they determined which nations rose and which fell, which cities prospered and which starved. Consider this. Throughout most of human history, salt was worth more than gold. Roman soldiers received portions of their wages in salt, the origin of our word salary. The Venetian Republic built its maritime dominance entirely on salt trading. The British Empire's taxation of salt in India sparked revolutions that would eventually drive them from the subcontinent. For 50 centuries, whoever controlled salt controlled the flow of commerce, the preservation of food, and the survival of populations. Salt routes carved pathways across continents. Salt taxes funded armies and built palaces. Salt monopolies toppled governments and crowned kings. Then refrigeration arrived. Within 2 decades, the most powerful commercial force in human history became a commodity you can buy for pennies at any grocery store. The speed of this collapse was unprecedented in economic history, faster than the fall of any empire, more complete than any military conquest. By 1920, salt empires stretched across every inhabited continent. The British controlled vast salt works in India that employed over 2 million people. French colonial salt operations in West Africa generated more revenue than gold mining. German chemical companies had transformed salt into the foundation of modern industry. American salt barons owned private armies that protected their operations across the Great Lakes region. These weren't merely businesses. They were sovereign powers that operated their own trade networks, maintained private militaries, and negotiated directly with national governments. The largest salt trading houses wielded influence comparable to modern multinational corporations, but with far less oversight and infinitely more direct control over human survival. The foundation of this power rested on a simple biological reality. Humans cannot survive without salt. Unlike other luxury goods that drove historical trade, salt was an absolute necessity. Every person needed roughly 10 grams of salt daily to maintain basic bodily functions. Every community required vast quantities for food preservation. Every nation depended on steady salt supplies to maintain social stability. Salt's preservation properties made civilization possible. Before refrigeration, salt was the only reliable method for storing meat, fish, and vegetables across seasons. Armies marched on salt-preserved provisions. Ships crossed oceans carrying salt-cured supplies. Cities survived winters through salt-preserved stores. Remove salt from human history, and you remove the possibility of permanent settlements, long-distance trade, and complex societies. The geographic distribution of natural salt deposits created inevitable power imbalances. While every population needed salt, only specific regions could produce it efficiently. Coastal areas offered sea salt through evaporation. Certain inland regions provided rock salt through mining. A few locations contained natural salt springs. These geological accidents of salt placement determined which societies would rise to power and which would remain dependent. The economics were straightforward but devastating for salt-poor regions. Salt-producing areas could essentially tax every meal eaten by neighboring populations. They could control the food security of entire nations by adjusting salt prices or restricting supply. They could fund military expansion through salt revenues, while weakening potential enemies by limiting their access to preservation technology. The story begins in 2800 BCE along the shores of the Mediterranean Sea, where Phoenician traders discovered that seawater left in shallow basins would evaporate to reveal crystalline deposits worth more than any precious metal they had previously encountered. These early salt producers could not have imagined they were founding an economic system that would dominate human civilization for the next 5 millennia. They knew only that their white crystals could preserve meat through summer heat, maintain fish stores through winter months, and command extraordinary prices from inland traders who had no alternative source for preservation technology. The Phoenicians developed the first systematic salt production methods around 2700 BCE. They constructed elaborate systems of terraced salt pans along coastlines, channeling seawater into shallow basins where Mediterranean sun and wind would concentrate the brine. Workers would rake the forming crystals into pyramidal mounds, then package the finished salt into ceramic containers for transport inland. Production volumes were initially modest. A typical Phoenician salt operation might produce 50 tons annually, enough to supply preservation needs for roughly 5,000 people. The economic returns were staggering. Inland communities would trade livestock, grain, metals, and manufactured goods at rates that effectively made salt worth 15 to 20 times its weight in silver. A single amphora of high-quality salt could purchase enough wheat to feed a family for 3 months, or enough bronze to forge a complete set of farming tools. The Phoenicians quickly recognized the strategic implications of salt control. They began establishing salt production sites at multiple coastal locations, creating the first international salt trading network. They developed specialized ships designed specifically for salt transport, with sealed compartments that protected the cargo from moisture during extended voyages. They trained navigators in routes that connected salt-producing regions with salt-hungry inland populations. By 2500 BCE, Phoenician salt traders had mapped routes extending from modern-day Spain to the eastern shores of the Black Sea. The wealth generated by salt trading transformed Phoenician society. Cities like Tyre and Sidon emerged as major urban centers supported entirely by salt commerce revenues. Phoenician shipbuilders developed increasingly sophisticated vessels capable of carrying larger salt cargoes across longer distances. Competition emerged from other coastal populations who recognized the potential of salt production. Greek settlements along the Aegean began developing their own salt operations. Egyptian communities in the Nile Delta started harvesting salt from coastal lagoons. The Phoenicians responded by developing more advanced production techniques that allowed them to maintain quality and cost advantages over competitors. More significantly, the Phoenicians began investing salt revenues in military capabilities. They built fortified ships that could protect salt cargoes from piracy. They established armed trading posts that could defend against local raiders. By 2200 BCE, the Phoenician salt empire had established the fundamental patterns that would characterize salt commerce for the next 4,000 years. They had demonstrated that control over salt production and distribution could generate sufficient wealth to fund military forces, diplomatic networks, and technological innovations. The pattern was established. Whoever controlled salt controlled civilization itself. The expansion of salt commerce beyond coastal regions required solving a fundamental challenge that would reshape the geography of human settlement. Salt was heavy, bulky, and vulnerable to moisture damage during transport, yet inland populations desperately needed regular supplies. The solutions developed by ancient traders created the first true international commerce networks and established pathways that would determine the location of major cities for millennia. Around 2400 BCE, Egyptian traders pioneered the first systematic inland salt transportation networks. They recognized that the Nile River provided an ideal route for moving large quantities of salt from Mediterranean production sites to inland population centers. Egyptian engineers developed specialized barges with sealed compartments designed specifically for salt transport, capable of carrying up to 30 tons of salt per voyage. The logistics were complex and expensive. Salt had to be packaged in waterproof containers made from animal hides or specially prepared ceramics. Loading and unloading required skilled workers who understood proper handling techniques to prevent contamination. River transport required extensive infrastructure, including docks, warehouses, and security facilities at regular intervals along transportation routes. The economic calculations justified these investments. Egyptian records from around 2200 BCE indicate that salt prices increased approximately fourfold between coastal production sites and inland markets 500 miles distant. Transportation costs consumed roughly 60% of this markup, but the remaining profits were still substantial enough to fund extensive commercial operations. Egyptian salt traders began establishing permanent commercial settlements at strategic points along transportation routes. These trading posts served multiple functions. They provided secure storage for salt cargoes, offered staging areas for organizing onward transport, and created local distribution centers for serving regional markets. Many of these trading settlements eventually developed into major cities as other commercial activities clustered around the salt trade infrastructure. The success of Egyptian salt commerce attracted competition from other regions, with geographic advantages for inland transportation. Mesopotamian traders began developing overland salt routes, using camel caravans capable of crossing desert regions where river transport was impossible. These caravans could carry smaller individual loads than river barges, but they could access markets that waterway transportation could never reach. Camel caravan salt trading developed different economic characteristics than river transport. Overland routes were more expensive per mile, but could command higher prices by accessing isolated markets with no alternative supply sources. Caravan trading required different skills, including desert navigation, animal management, and diplomatic relations with tribal groups who controlled key crossing points. The Mesopotamians pioneered the development of oasis-based trading networks that created permanent infrastructure for desert salt commerce. They established fortified trading posts at natural water sources along caravan routes, providing secure storage and resupply facilities for salt traders. These oasis settlements became crucial control points that could determine which trading groups gained access to specific markets. By 2000 BCE, competing salt trading networks had established routes connecting virtually every major population center in the Mediterranean and Near Eastern regions. Egyptian river-based networks dominated the Nile Valley and Eastern Mediterranean coastal trade. Mesopotamian caravan networks controlled desert routes extending from the Persian Gulf to the Levantine coast. Phoenician maritime networks linked coastal production sites with island markets and distant colonial settlements. Competition between these networks drove rapid innovations in transportation technology and commercial organization. Traders developed increasingly sophisticated preservation techniques for protecting salt during long-distance transport. They established standardized weights and measures that allowed for efficient trade between different regional networks. The competitive dynamics also drove expansion into previously untapped markets. Salt traders began exploring routes into Central Asian regions, African interior populations, and European tribal territories. These expansion efforts required major investments in exploration, route development, and relationship building with previously unknown populations. The Central Asian expansion proved particularly significant. Around 1800 BCE, salt traders discovered that certain Central Asian populations had developed sophisticated metalworking techniques, but lacked reliable salt supplies. This created opportunities for extremely profitable long-distance trade, exchanging salt for bronze goods, weapons, and precious metals that could be sold in other markets. The African expansion opened access to gold-producing regions that were eager to trade precious metals for salt and other preservation technologies. Salt traders established routes extending hundreds of miles into the African interior, creating commercial relationships with populations that had previously been isolated from international trade networks. By 1600 BCE, salt trading routes had created the world's first truly global commercial network. These routes connected populations across 3 continents, facilitating not just salt commerce, but the exchange of technologies, ideas, and cultural practices that would accelerate human development across vast geographic regions. The political implications were profound. Rulers who controlled key points along salt trading routes could generate enormous revenues through taxation and regulation. Salt routes had become the circulatory system of ancient civilization, carrying the essential commodity that made complex societies possible. The Roman Empire's systematic exploitation of salt as a foundation for political and military power created the template that would be copied by empire builders for the next 2,000 years. Roman innovations in salt production, taxation, and distribution demonstrated how control over this essential commodity could be transformed into unprecedented territorial expansion and administrative control. Roman salt operations began around 753 BCE, with small-scale production facilities along the Italian coastline near the mouth of the Tiber River. These early operations were modest, producing perhaps 200 tons annually to supply the growing settlement that would become Rome. The transformation began around 600 BCE, when Roman leaders recognized that salt's unique characteristics, universal necessity combined with limited production sites, created opportunities for systematic revenue generation that could fund military expansion. Roman engineers began developing the most sophisticated salt production facilities in the ancient world, incorporating advanced evaporation techniques, crystallization control methods, and large-scale processing capabilities. The Romans pioneered the industrial organization of salt production, They constructed massive salt works covering hundreds of acres with elaborate systems of channels, basins, and processing facilities that could produce thousands of tons annually. They developed specialized labor systems with trained workers responsible for specific aspects of production, from seawater collection and concentration to crystal harvesting and packaging. Quality control became a distinctive feature of Roman salt operations. Roman producers developed multiple grades of salt for different uses: finest quality for wealthy households, medium grade for general food preservation, and coarse grade for industrial applications like leather processing and textile dyeing. The military applications of salt provided the foundation for Roman expansion strategy. Roman armies were among the first to develop systematic provisioning systems that allowed for extended military campaigns far from supply bases. Salt preservation enabled Roman forces to carry sufficient food supplies for months-long operations, while enemy forces remained limited to areas where they could forage for fresh provisions. Roman military engineers developed portable salt processing equipment that allowed armies to establish temporary salt production facilities during extended campaigns. These mobile operations could process seawater or brine springs to produce salt for preserving captured livestock and local food sources, extending the operational range of Roman forces beyond any previous military capability. The economic implications were equally revolutionary. Around 500 BCE, Roman authorities implemented the first systematic salt taxation system, imposing levies on both production and distribution that generated substantial revenues for the state treasury. These salt taxes provided funding for road construction, military equipment, administrative salaries, and public works projects that strengthened Roman control over conquered territories. Roman salt taxation was remarkably sophisticated for its era. Tax rates varied by salt quality and intended use, with luxury grades taxed at higher rates than basic preservation salt. Tax collection was centralized through professional administrators who maintained detailed records of production volumes, distribution patterns, and revenue generation. Roman expansion strategy explicitly incorporated salt considerations. Roman military commanders prioritized the conquest of salt-producing regions and established secure control over salt transportation routes. Roman colonial administration focused heavily on developing salt production capabilities in newly conquered territories, both to supply local Roman populations and to generate revenues for the imperial treasury. The Roman salt monopoly system became increasingly sophisticated over time. By 400 BCE, Roman authorities had established exclusive control over salt production and distribution throughout Italian territories. Private salt trading was prohibited, and all salt commerce was conducted through government-controlled operations that ensured maximum revenue generation for the state. Roman salt distribution networks extended across the entire Mediterranean region by 200 BCE. Roman engineers constructed specialized infrastructure, including salt roads, storage facilities, and transportation systems that could reliably supply salt to populations throughout the empire. The wealth generated by salt operations funded some of the most impressive achievements of Roman civilization. Salt revenues contributed to the construction of roads, aqueducts, public buildings, and military fortifications that demonstrated Roman power to subject populations. By 100 BCE, Roman salt operations had demonstrated the full potential of systematic commodity control as a foundation for imperial power. The Romans had proven that salt could provide not just commercial profits, but the economic foundation for sustained territorial expansion, administrative control, and cultural influence that would endure for centuries. Roman salt empires lasted for over 800 years, demonstrating the durability of salt-based power when properly organized and systematically exploited. The Venetian Republic's transformation of salt from a trading commodity into a monopolized strategic weapon created the most sophisticated economic control system in medieval Europe. Between 1500 CEE, Venetian salt operations evolved from modest commercial enterprises into a comprehensive system of market manipulation that generated wealth sufficient to fund armies, fleets, and architectural projects that dominated the Mediterranean world. Venetian salt monopolization began around 1050 CE, when the Republic's leaders recognized that their geographic position provided unique opportunities for controlling salt distribution to northern European markets. Venice possessed excellent access to Mediterranean salt production sites, while controlling key alpine passes that provided the only practical routes for transporting salt to populations in Germany, Austria, and Eastern Europe. The Venetians developed the first truly systematic approach to monopoly creation and maintenance. They began by establishing exclusive trading agreements with salt producers across the Mediterranean, guaranteeing purchase of entire annual productions in exchange for guaranteed prices and exclusive distribution rights. These agreements eliminated competition between different production sites and gave Venice unified control over supply availability. Venetian merchants invested heavily in transportation infrastructure, designed specifically for salt commerce. They constructed specialized ships with sealed cargo holds, capable of protecting salt from moisture damage during extended voyages. They built warehouses with advanced ventilation and humidity control systems that could store vast quantities of salt without deterioration. The economic scale of Venetian salt operations was unprecedented in medieval Europe. By 1200 CE, Venice was importing over 50,000 tons of salt annually from production sites across the Mediterranean. Venetian warehouses could store enough salt to supply northern European markets for entire years, providing complete control over supply timing and pricing decisions. Venetian salt pricing strategies were sophisticated and ruthless. They maintained artificially high prices in markets with no alternative supply sources, while using selective price cuts to eliminate competitors who attempted to establish alternative distribution networks. They coordinated pricing across multiple markets to maximize overall revenues while preventing the emergence of parallel trading systems. The Venetians pioneered the use of financial instruments for commodity market manipulation. They developed futures contracts that allowed them to secure salt supplies months or years in advance at fixed prices, then sell those supplies at market rates that they could influence through their control over distribution. They used credit systems to bind customers to exclusive purchasing agreements that prevented those customers from seeking alternative suppliers. Market intelligence became a crucial component of Venetian salt operations. Venice maintained networks of informants throughout Europe who provided detailed information about local salt supplies, consumption patterns, and potential competitors. The Venetians also developed vertical integration strategies that extended their control beyond simple trading operations. They began investing directly in salt production facilities, providing capital for expanding existing operations and establishing new production sites in exchange for guaranteed supply agreements. They acquired shipping companies, warehouses, and financial institutions that supported salt commerce, creating comprehensive control over every aspect of the salt trade. Political manipulation accompanied economic control. Venice used salt revenues to fund diplomatic operations that influenced government policies in salt-consuming regions. They provided loans to rulers in exchange for favorable trading regulations. The Venetian salt monopoly generated extraordinary wealth that transformed the Republic into a major European power. Salt revenues funded the construction of Venice's famous architecture, including St. Mark's Basilica and the Doge's Palace. Salt profits enabled Venice to maintain the largest naval fleet in the Mediterranean and professional armies capable of competing with major European kingdoms. By 1300 CE, Venetian salt operations had become so dominant that disruptions to their supply networks could cause food crises across northern Europe. Venice possessed what economists would now recognize as near-complete market power over an essential commodity, with the ability to influence prices and availability across vast geographic regions. The monopoly's success attracted increasing attention from European rulers who recognized both the revenues that salt control could generate and the strategic vulnerabilities created by dependence on Venetian supplies. Multiple kingdoms began attempting to develop alternative salt sources or establish independent distribution networks that could bypass Venetian control. Venice responded to competitive threats with increasingly aggressive tactics. They used their naval forces to disrupt alternative supply routes. They provided financial support to allies who could pressure competitors. The technological requirements for maintaining the monopoly drove innovations that extended far beyond salt trading. Venetian shipbuilders developed increasingly sophisticated vessels capable of carrying larger cargoes more efficiently. By 1400 CE, the Venetian salt monopoly had demonstrated the full potential of systematic market control as a foundation for political and economic power. Venice had proven that monopolization of essential commodities could generate wealth and influence comparable to territorial empires, while requiring fewer military resources and administrative expenses. The Venetian model would inspire numerous attempts at commodity monopolization throughout subsequent centuries, though few would achieve the comprehensive market control and sustained profitability that characterized Venice's salt operations. Venice's salt empire lasted for over 4 centuries, making it one of the longest-running successful monopolies in economic history. The British Empire's salt operations in India represented the largest and most systematically exploitative salt monopoly in human history. Between 1757 and 1947, British authorities controlled Indian salt production and distribution through a comprehensive legal and administrative system that generated hundreds of millions of pounds in revenue while imposing devastating economic burdens on Indian populations. The British salt monopoly began after the Battle of Plassey in 1757, when the British East India Company gained control over Bengal and began systematically exploiting the region's natural resources. Salt production along India's extensive coastline provided immediate opportunities for revenue generation through monopolization and taxation. By 1780, British authorities had established exclusive control over salt production throughout Bengal, prohibiting private salt manufacturing and requiring all salt commerce to occur through British-controlled channels. The monopoly expanded rapidly as British territorial control extended across India. By 1850, British salt operations covered over 4,000 square miles of coastal production facilities and employed more than 2 million workers. Annual salt production exceeded 2 million tons, making British India the world's largest salt producer. The British implemented a comprehensive taxation system that imposed charges at multiple points in the salt supply chain: production taxes, transportation taxes, and sales taxes that combined to make Indian salt prices 5 to 10 times higher than production costs. The economic exploitation was systematic and ruthless. British authorities set salt prices to maximize revenue extraction, regardless of the burden on Indian consumers. Salt taxation generated annual revenues exceeding £10 million in 10 monetary, making it one of the largest sources of colonial government income. The tax burden fell disproportionately on India's poorest populations, who spent substantial portions of their limited incomes on essential salt purchases. Indian subjects were prohibited from producing their own salt, even for personal consumption. Violation of salt regulations was treated as criminal sedition, with penalties including imprisonment, property confiscation, and transportation to penal colonies. The administrative apparatus required for monopoly enforcement was extensive and oppressive. British authorities established a parallel police force of salt tax collectors with broad powers to search homes, confiscate property, and arrest suspected violators. These officials operated with minimal oversight and frequently abused their authority, creating widespread resentment among Indian populations. The salt monopoly became a powerful symbol of colonial exploitation and economic injustice. Indian nationalist leaders recognized that salt taxation represented a grievance that affected virtually every Indian regardless of region, religion, or social class. Salt became a focal point for anti-colonial resistance and political mobilization. Gandhi's Salt March in 1930 transformed salt from an economic issue into a political weapon against British rule. Gandhi's decision to walk 240 miles to the coastal village of Dandi to illegally produce salt was strategically brilliant in its simplicity and devastating in its effectiveness. The image of Gandhi breaking British salt laws by picking up natural salt crystals from the beach became one of the most powerful symbols of anti-colonial resistance in modern history. The British response demonstrated both the importance of salt revenues to colonial finances and the political unsustainability of the monopoly in the face of mass civil disobedience. British authorities arrested over 60,000 people for salt law violations following Gandhi's march, but could not prevent the collapse of public support for salt taxation. The salt monopoly's economic foundations were simultaneously being undermined by technological changes occurring worldwide. Refrigeration technology was eliminating traditional salt preservation markets in developed countries, and this transformation was beginning to affect Indian markets as well. By 1930, refrigeration equipment was being imported to India in increasing quantities, particularly in urban areas where electric power infrastructure was being developed. The British attempted to maintain salt revenues by expanding taxation to industrial applications and imposing higher rates on remaining traditional uses, but these efforts proved counterproductive as they accelerated the adoption of alternative preservation methods. By 1935, British colonial officials were questioning whether salt operations generated net revenues after accounting for administrative expenses. The extensive enforcement apparatus required for monopoly control had become economically unjustifiable as revenues declined and political resistance intensified. Internal British government documents from this period reveal bureaucratic panic as salt revenues collapsed. Colonial Secretary Leopold Amory noted that the salt revenues which have sustained Indian administration for generations may disappear entirely within a decade. By 1940, British salt revenues in India had declined to less than £2 million annually, representing an 87% decline from 1920 peak levels. The British salt monopoly in India finally ended with Indian independence in 1947, but the economic foundations had collapsed over a decade earlier due to refrigeration technology and political resistance. The British experience demonstrated that even the most comprehensive and ruthlessly enforced commodity monopolies could be destroyed by technological change and political mobilization. The Indian salt monopoly had lasted for 190 years, making it one of history's longest-running systematic exploitation schemes, but it proved vulnerable to forces that British authorities could neither control nor effectively resist. The mechanization of salt production during the 18th and 19th centuries transformed salt from an artisanal craft into modern industrial manufacturing, dramatically increasing production volumes while simultaneously beginning the process that would eventually undermine salt's strategic value. British innovations in steam-powered salt production created the first truly industrial salt operations and established patterns of technological development that would characterize all subsequent industrial commodity production. British salt industrialization began around 1750 in Cheshire, where natural brine springs provided raw materials for salt production, but traditional evaporation methods were limited by England's unreliable climate. British engineers recognized that steam power could provide consistent heat sources for salt evaporation, independent of weather conditions, enabling year-round production at much higher volumes than previous methods allowed. The first steam-powered salt works were established near Northwich in 1758. These facilities used coal-fired steam engines to heat large iron pans filled with brine, creating controlled evaporation conditions that could produce salt continuously regardless of external weather. Initial production capacity was modest, perhaps 50 tons weekly, but represented a substantial increase over traditional solar evaporation methods. Production volumes increased rapidly as steam technology was refined and expanded. By 1780, Cheshire steam salt works were producing over 10,000 tons annually. By 1820, annual production had exceeded 50,000 tons from a single regional complex. These volumes were unprecedented in salt production history and created entirely new possibilities for salt commerce and industrial applications. The economic implications were profound and contradictory. Industrial production dramatically reduced salt production costs, making salt affordable for applications that had previously been economically impractical. Lower costs enabled the development of chemical industries that used salt as raw material for producing alkalis, acids, and other industrial chemicals. Reduced prices made salt preservation accessible to broader populations. Simultaneously, industrial production began undermining the scarcity that had made salt politically and economically strategic for millennia. When salt could be produced in virtually unlimited quantities at relatively low costs, the monopolization strategies that had enabled salt empires became increasingly difficult to maintain. British industrial salt producers quickly recognized the global implications of their technological advantages. They began exporting both salt and salt production equipment to markets throughout the British Empire and beyond. British engineers established industrial salt operations in India, Canada, Australia, and other territories where traditional production methods had previously dominated. Competition emerged from other European industrial regions that possessed the technological capabilities and resource access necessary for steam-powered salt production. German chemical companies began developing industrial salt operations that integrated salt production with broader chemical manufacturing processes. American industrial development created particularly significant competition for British salt producers. The United States possessed abundant coal reserves, extensive water transportation networks, and growing domestic markets that provided ideal conditions for large-scale salt production. American entrepreneurs began establishing industrial salt facilities around the Great Lakes region, taking advantage of natural brine deposits and excellent transportation access. The Syracuse salt operations in New York State became the most impressive example of American industrial salt production. By 1860, Syracuse facilities were producing over 7 million bushels of salt annually, making them among the largest salt production operations in the world. Technological competition drove continuous innovations in industrial salt production throughout the 19th century. Producers developed more efficient heating systems that reduced coal consumption. They pioneered mechanical handling systems that reduced labor costs. They created quality control processes that ensured consistent product standards across large-scale operations. The integration of salt production with chemical manufacturing became increasingly important as industrial applications for salt expanded. Salt became a crucial raw material for producing soap, glass, textiles, and numerous other manufactured products. By 1850, industrial salt production had fundamentally altered the global salt trade. Traditional salt empires that had dominated international commerce for centuries found themselves competing with industrial producers who could offer superior products at lower prices. The economic foundations of salt-based political power were beginning to erode as salt transitioned from a scarce strategic resource to an abundant industrial commodity. The transformation was still incomplete in 1850, and traditional salt trading retained significant market share in regions where industrial production had not yet been established. However, the technological and economic trends were clear. Industrial production would eventually make salt so abundant and affordable that it could no longer serve as a foundation for monopolistic control or strategic political power. The Industrial Revolution had begun the process that would eventually eliminate salt's 5,000-year dominance as humanity's most strategically important commodity. The development of practical refrigeration technology between 1870 and 1930 initiated the most rapid and complete collapse of strategic commodity value in economic history. Mechanical refrigeration eliminated salt's monopoly over food preservation, destroying the foundation of economic power that had sustained salt empires for 5,000 years in a transformation so swift that contemporary observers struggled to comprehend its implications. Mechanical refrigeration emerged from 19th century advances in thermodynamics and industrial engineering that enabled the artificial production of sustained low temperatures. The scientific principles were understood by 1850, but practical applications required decades of technological development to create reliable, efficient, and economically viable systems for preserving food through controlled cooling rather than chemical preservation. The first commercial refrigeration systems were developed in the 1870s for large-scale industrial applications, including meat packing, brewing, and ice production. These early systems were enormous, expensive, and technically complex, requiring skilled operators and substantial infrastructure investments. Initial refrigeration facilities cost tens of thousands of dollars and consumed significant amounts of energy, making them practical only for major commercial operations. Despite these limitations, commercial refrigeration proved enormously valuable for businesses that could afford the initial investments and operational costs. Meat packing companies could process larger volumes and maintain product quality during extended storage periods. The transformation accelerated dramatically with the development of electric refrigeration during the 1910s. Electric motors proved more reliable than steam-powered compressors and enabled the development of smaller systems suitable for retail stores, restaurants, and institutional applications. Mass production techniques developed during World War I enabled manufacturers to reduce refrigeration equipment costs substantially. Standardized components, assembly line production methods, and improved manufacturing technologies made electric refrigeration systems accessible to much broader markets. By 1920, refrigeration equipment costs had declined by over 60% from 1910 levels. The introduction of household electric refrigerators in the 1920s created the technological foundation for eliminating salt's preservation monopoly at the consumer level. Early household refrigerators were still expensive, typically costing the equivalent of several months' wages for average workers, but they demonstrated the potential for universal access to artificial preservation technology. Consumer adoption of refrigeration technology accelerated rapidly during the 1920s. Household refrigerator ownership increased from fewer than 1% of American homes in 1920 to over 15% by 1930. Similar adoption rates occurred in Europe, where electric power infrastructure and household incomes reached levels that made refrigeration affordable for middle-class families. The technological improvements continued throughout the 1920s. Refrigerant technology advanced with the development of Freon, which was safer and more efficient than previous refrigerants. Compressor design improved reliability and reduced energy consumption. Insulation materials became more effective at maintaining consistent temperatures with lower energy requirements. The economic implications for salt markets were devastating and accelerated throughout the decade. Household food preservation no longer required substantial salt purchases. Commercial food producers could maintain product quality through refrigerated storage and transportation, rather than salt preservation. Salt consumption patterns changed rapidly in markets where refrigeration technology became widely available. Traditional salt preservation methods were abandoned for most food products, except in specialized applications where salt provided flavor benefits rather than preservation necessity. Salt purchases by average households declined by 70% in regions with widespread refrigeration adoption. The response from salt producers was inadequate to address the scale and speed of market transformation. Some salt companies attempted to develop new markets for salt in industrial applications, but these markets were much smaller than traditional food preservation uses. Salt trading networks that had dominated international commerce for centuries found their core markets disappearing within a single decade. The speed of transformation was unprecedented in the history of commodity markets. Salt had maintained its strategic importance for over 5,000 years through countless technological, political, and economic changes. Refrigeration destroyed salt's preservation monopoly completely within 20 years from the introduction of practical household refrigeration systems. Regional variations in refrigeration adoption created temporary opportunities for traditional salt operations, but these opportunities were quickly eliminated as electric power infrastructure and refrigeration technology spread to previously unserved markets. By 1940, refrigeration was available in virtually all developed regions. The collapse of salt's strategic importance eliminated one of humanity's oldest and most persistent sources of economic and political power. Salt empires that had dominated civilization for millennia became historical curiosities within a generation. The rapidity and completeness of this transformation provided unprecedented lessons about the potential for technological disruption to eliminate established economic systems. The period between 1930 and 1950 witnessed the complete collapse of salt empires that had dominated global commerce for 5 millennia. As refrigeration technology achieved universal adoption and alternative preservation methods eliminated salt's monopoly over food storage, this transformation occurred with breathtaking speed, destroying economic and political structures that had seemed permanent and unassailable just decades earlier. The scale of the British salt infrastructure in India was staggering. Over 4,000 square miles of salt production facilities stretched along the Indian coastline. These operations employed 2.3 million workers directly, with an additional 800,000 people dependent on salt-related activities. The administrative apparatus included over 15,000 officials who managed taxation, production quotas, and distribution networks. The economic collapse was accelerated by political developments that reduced British ability to maintain monopolistic control. Gandhi's Salt March in 1930 challenged British salt taxation through civil disobedience that inspired widespread resistance. The symbolic power of salt taxation as representation of colonial exploitation made salt operations politically unsustainable even before economic forces eliminated their profitability. The British response demonstrated desperation of salt empire managers facing technological obsolescence. Colonial authorities attempted to maintain salt revenues by expanding taxation to industrial applications and imposing higher rates on remaining uses. Salt tax rates were increased by 40% in 1932, despite declining demand, creating a vicious cycle where higher prices accelerated adoption of alternative preservation methods. Internal British government documents from this period reveal bureaucratic panic as salt revenues collapsed. Colonial Secretary Leopold Amory noted in 1934 that salt revenues, which have sustained Indian administration for generations, may disappear entirely within a decade. Treasury officials calculated that maintaining the salt monopoly infrastructure cost over £8 million annually by 1936, while revenues had fallen to £6 million. The technological transformation was visible in statistical data. Refrigeration equipment imports to India increased by 2,300% between 1930 and 1940. Household refrigerator ownership in Indian cities grew from virtually zero in 1930 to over 12% by 1940. The French colonial salt empire experienced similar collapse in West African territories, where refrigeration technology and improved food distribution networks eliminated traditional preservation requirements. French salt operations that had employed over 100,000 workers in 1925 were reduced to fewer than 10,000 workers by 1940, as production facilities were closed or converted to other industrial applications. French salt companies attempted to maintain operations by expanding into European markets, where refrigeration adoption was slower. But this strategy failed, as European refrigeration adoption accelerated during the 1930s, and European salt producers protected their domestic markets through tariffs. American salt companies experienced the most rapid market transformation because refrigeration adoption rates were highest in the United States. The Michigan Salt Association saw demand for preservation salt decline by over 85% between 1925 and 1935. Many member companies were forced to cease operations or completely restructure their business models. The town of Syracuse, New York, known as the Salt City for over a century, saw its salt workforce decline from over 8,000 workers in 1920 to fewer than 500 workers by 1940. The infrastructure investments that had sustained global salt networks became massive economic burdens as markets disappeared. Global salt production capacity in 1930 exceeded 25 million tons annually, housed in facilities that had cost the equivalent of over $500 million to construct. Transportation networks specifically designed for salt commerce included thousands of specialized ships, railroad cars, and warehouses that had no alternative commercial applications. Salt production facilities were particularly difficult to convert to alternative uses. Solar evaporation facilities required large areas of shallow basins that could not easily be adapted to other industrial applications. The speed of transformation caught most observers by surprise. Economic analysts and salt industry leaders had generally expected refrigeration to complement rather than replace salt preservation methods. The assumption was that refrigeration would serve luxury markets while salt continued to dominate mass-market food preservation. The reality proved dramatically different. Consumer behavior changed much more rapidly than anticipated. Once households gained access to refrigeration, they quickly abandoned salt preservation methods almost entirely. The convenience and superior quality of refrigerated food storage created consumer preferences that eliminated demand for salt preservation, even when salt remained available at competitive prices. By 1950, the salt empires that had shaped human civilization for 5,000 years had been reduced to minor industrial operations serving specialized niche markets. The economic and political power that had been based on salt control had evaporated as completely as if it had never existed. The transformation from strategic resource to industrial commodity was so complete that younger generations could barely comprehend how salt had once been more valuable than gold. The transformation of salt from humanity's most strategic resource into an ordinary industrial commodity was complete by 1950, creating a new economic reality where salt's abundance and accessibility eliminated forever the possibility of salt-based empire building. The modern salt industry operates according to completely different principles than the strategic commodity systems that had dominated civilization for 5 millennia. Contemporary salt production exceeds 300 million tons annually worldwide, representing more than a 100-fold increase from peak production during the height of salt empires. This production capacity far exceeds all possible preservation applications, even if refrigeration technology was suddenly unavailable. Industrial salt operations now function as low-margin commodity businesses focused on cost efficiency and volume production rather than strategic control and price manipulation. Major salt producers compete primarily on cost and reliability rather than scarcity and exclusivity. Profit margins in commodity salt production rarely exceed 5–8% compared to the 500–1000% margins that characterized salt empires during their peak periods. The geographic distribution of salt production has been completely democratized through technological advances that enable efficient production in virtually any location. Solar evaporation, rock salt mining, solution mining, and seawater processing technologies can be implemented wherever basic infrastructure and energy sources are available. The primary markets for salt have shifted dramatically from food preservation to industrial applications that would have been unimaginable to historical salt traders. Chemical manufacturing consumes over 60% of global salt production for producing chlorine, caustic soda, and numerous other industrial chemicals. Road de-icing operations consume approximately 20% of production in temperate climate regions. Food applications account for less than 5% of total salt consumption. These industrial applications operate according to completely different economic principles than food preservation markets. Consumer salt purchases have stabilized at levels that would have seemed impossibly low to historical observers. Average household salt consumption in developed countries is approximately 2–3 pounds annually per person, with most of this consumption for cooking and table use rather than preservation. A typical family's annual salt expenditure represents less than $10, making salt economically insignificant in household budgets. The pricing structure for salt reflects its commodity status rather than strategic value. Retail salt prices in developed markets typically range from 50 cents to $2.00 per pound, depending on packaging and quality specifications. The regulatory environment for salt production and trading is minimal compared to other commodity markets. Salt is generally treated as a safe industrial material requiring basic environmental and safety compliance, but no strategic resource controls. Government involvement in salt markets typically focuses on quality standards, environmental protection, and worker safety rather than economic regulation or strategic oversight. The institutional knowledge of salt empire operations has been largely lost as the industry transitioned to commodity production. Few contemporary salt companies maintain historical records or institutional memory of strategic salt trading methods. The lessons from salt's transformation have influenced thinking about strategic resource management and technological disruption more broadly. The speed and completeness of salt empire collapse demonstrated that even the most established and seemingly permanent economic structures can become obsolete when technological alternatives eliminate the scarcity that enabled strategic control. Modern strategic resource management recognizes that technological change can eliminate resource scarcity much more rapidly than historical experience suggested. The salt example provides crucial insights about the potential for technological disruption to undermine resource-based power structures that appear to be permanent and unassailable. When viewed across the full arc of human history, salt's rise and fall as a strategic resource reveals fundamental truths about the relationship between technology, economics, and power that extend far beyond any single commodity or historical period. The 5,000-year dominance of salt empires seemed so permanent and unshakable that contemporary observers could barely imagine alternatives to salt-based preservation systems. The speed and completeness of salt's strategic collapse challenges conventional assumptions about the stability of resource-based power structures. The salt example demonstrates that technological alternatives can eliminate resource scarcity so rapidly and thoroughly that established power structures become obsolete within single decades. The political lessons are equally significant. Salt taxation and monopolization created governmental capabilities and administrative systems that influenced the development of modern state institutions. The resistance to salt taxation contributed to political movements and revolutionary activities that shaped democratic governance. Contemporary strategic resource markets show some parallels to historical salt empire patterns. Rare earth minerals, lithium deposits, semiconductor materials, and other technology-critical resources currently exhibit scarcity characteristics that enable strategic control similar to historical salt operations. The salt example suggests that technological alternatives could potentially eliminate these scarcities more rapidly than current market participants anticipate. The salt transformation also demonstrates the potential for technological change to democratize access to essential capabilities that were previously monopolizable. Refrigeration eliminated salt preservation monopolies by making superior preservation technology accessible to virtually all populations. Similar technological developments could potentially democratize access to other currently scarce strategic resources. The speed of transformation created social and economic disruptions that governments and institutions struggled to address effectively. The salt industry's collapse occurred faster than educational systems could retrain workers, faster than financial institutions could adjust their lending practices, and faster than governments could modify their economic policies. The salt story ultimately reveals that human ingenuity consistently develops alternatives to scarcity-based power structures, even when those structures appear to be permanent features of civilization. The 5,000 years of salt empire dominance represents humanity's longest-running strategic resource system, yet it proved vulnerable to technological innovation that eliminated its fundamental scarcity advantage. This pattern suggests grounds for optimism about humanity's ability to overcome resource constraints and power imbalances that currently seem intractable. The same innovative capabilities that created refrigeration technology continue to develop new solutions to resource scarcity problems. If you made it through this entire story, drop a in the comments. I'd be curious whether you knew that salt was once more valuable than gold, or that entire empires were built on controlling it. Most people think of salt as just a cheap seasoning, not realizing it shaped human civilization for 5,000 years until one invention made it nearly worthless in 20 years. If you want to see more about how technology destroys established power structures, check out my video on how the automobile industry killed the railroad empires. It's a similar pattern of disruption happening even faster. Thanks for watching. See you in the next one.